Hey everybody, we are going to talk about, let's see, we're going to talk about this one for a minute. This says, develop a mathematical model for the number of squares in the logo for size n. So what we want to do is try to figure out, I'm going to start with maybe a chart. There's lots of ways to do this. I think the first thing actually to do is to observe some things. So size 1 has one square in the middle and then like 3 on the top, 3 on the bottom. Size 2 has 2 in the middle, has 5 on the top and 5 on the bottom. I'm also noticing that like there are 2 squares here and 2 here, and that kind of matches with that, which is sometimes helpful. There's 2 squares at all of these places, right? Size 3, I see 3 and 3 and 3 and 3 and 3. Now there are 2 extra squares. You see this one and this one right here that aren't, let's see, and this one. Let's see, no, not this one. Let's see if I can erase that. This one is part of the 3. Yeah. So these 3, 3, 3, 3, 3, but there's 2 extras. There's 2 extras right here too. Oh, and this one has 1, 1, 1, 1, 1, and it's got 2 extras that we're not really looking at yet. Okay, and the same pattern holds for 4. So let's kind of keep an eye on that for a minute. Let's make a chart. Okay, make a basic chart. We'll go X for, actually we'll do N because it's asking for N. Let's go N and then F of N. Okay, we're going to see what happens. F of N is going to be the number of blocks or the number of squares, and N is going to be the size. So size N. So when size N is 1, there are 7 squares. When it's size 2, there are, let's see, 10. 5 times 2 is 10 plus 2 is 12. 3 is 3 plus 7 times 2. 7 times 2 is 14 plus 3 is what, 17? Okay, and 4 is 20, what is that, 22? 1, 2, 3, 4, 5, 6, 7, 8, 9, 18 plus 4 is 22. 22 blocks. Okay, and so I'm going to quickly look at my first difference to see if this is linear. This is going to be 7. To get to 12 from 7, you have to add 5. To get from 12 to 17, you have to add 5. This is going to be a linear equation. Okay, if these are the same, then the equation is going to be linear, which kind of tells us something. We're going to have something that looks probably something like this. Mx plus b. That's my guess. Okay, because it's going to be linear. There's going to be a slope of how much this thing is going to increase, and then some y-intercept. Okay, we're going to have to figure this out. The y-intercept, let's talk about this guy for a minute. The y-intercept is where the function hits the y-axis. So somewhere along here, could be down here in the negative, somewhere this line is going to hit the y-intercept. It's going to hit the y-axis somewhere on here. It's going to cross the y-axis. And when it crosses the y-axis, x, or actually n, let's go n, because we're working with n today. N is our independent variable. Okay, n. N is going to have to be 0 somewhere, because here's 0 for n. So what we can do is actually, like, you can squish in a little 0 right here, and you can say when n is 0, what will f of n be? And because we know we're adding 5 each time, this minus 5 is going to be 2. Okay, so that you can still have your plus 5 difference right there. So this is kind of a cheater way to figure out what b is, what this guy is going to be. So if you go f of x equals the slope, which, guess what, guys? First difference, that's the slope. 5x plus 2. Okay, because 2 is the intercept, is the y-intercept. Where n is 0, this is what f of n is, and that's the y-intercept when n is 0. Okay, so here is our equation. And that is one way that you can do that. That's like a really mathematical way to do this. Let's do it another way really quick too. Let's look at a different way. So I'm going to clear all of this out, and let's just look at some patterns for a minute. Okay, we have when n is 1, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 ones. Okay, so I can say if n is 1, you can do n times 5. There are 5 of them. Plus 1 extra square and 1 extra square plus 2. That's equal to f of n. Cool, huh? Right here you can say you have 1, 2, 3, 4, 5 times 2, which is n. 5n plus 1, 2 extra squares. Okay. Here's another way you can try to figure it out, just by looking at some of the patterns, looking at some of the things that are going on. But look, that's the same equation. Isn't that rad? Anyway, hope that helps. Please write all of those notes down if you were not in class.